disciplines of agricultural economics. And okay, it's a pleasure to invite Professor Kawasaki Kentaro from the University of Tokyo for giving us a speech about rice analysis of Japan. And I'm also pleased that Professor Indru Chen can join the speech. Okay, now I would like to invite Professor Kawasaki for giving us the opening address and begin the speech. Okay, 那我们给他掌声一下，好，谢谢。
Thank you, Professor Chen. Thank you very much for coming today. My name is Kentaro Kawasaki from the University of Tokyo. And I'm very happy to be here because I made a presentation last year and 2 years ago using online. But finally, in this third year, I could come to Taiwan. So I'm very, very happy to be here. See you in person. Yeah, that's all, and let me start my presentation. Okay. So the title is "Quality Matters More Than Quantity" and Asymmetric Temperature Effects on Crop Yield and Quality Grade. So background. So as you know, agriculture is the most climate sensitive sector, and literature on climate change on agricultural field mainly focus on the impact on quantity or crop yield. So it's a weight produced per acreage of the land. Okay. But how about the quality? That is my research question. And does climate change affect farm income through quantity or quality? That is today's my presentation. But well, quantity is easily measured, right? It's measured by kilogram or ton, very easy. But quality is very hard to measure. And there are several different measurements of quality. The first one is attribute. For example, protein contents in rice or grain size, etc. And the second one, that is my focus today, is a grading standard. Okay. For example, government of Japan and in many countries, probably in Taiwan as well, impose some grading rules. So this rice is first grade and this rice is second grade and so on. So that is another measurement of quality. And the last one is price. Okay. Price, of course, reflects all possible attributes of quality. Okay. And yeah, this small table summarizes the difference of each measurement. Okay. Attribute can reflect only one attribute, right? For example, if you use protein content, it can only reflect protein content, right? So you should have many different variables to analyze. Okay. And there are lots of literature on the attributes of crops, mainly in natural science field. And yeah, price, as I said, it will virtually reflect all possible qualities that consumers can see. And there are lots of literature on this as well, called hedonic approach. And the second one, grade, reflects only several quality attributes, as I will show you later. And but there are very few literature, okay, few economics papers on the grading standard. So that is why I focus on grade. So this is a grading standard of rice in Japan. In Japan, rice is classified into 4 grading categories: first, second, third, and fourth. And based on these characteristics. So, for example, this shows the minimum limits. First grade rice should have more than 70% of head rice. Okay. head rice refers to the rice which is not damaged, okay, or colored, etc. And this is the maximum limits. Okay, for example, moisture level should be less than 15%, and colored kernel should be less than 0.1%, etc. So this is a picture of first grade rice, second grade, and fourth grade rice. Okay. For example, fourth grade rice includes colored grains, and they are typically very small in shape. And on average, in Japan, first grade rice accounts for nearly 70%, and second grade for 25%. And third and fourth grade is very rare. Okay. And the price of each grade is as follows. Okay. Compared to first grade rice, they are lower prices. Okay. And the relationship between heat and rice quality is as follows. Okay. In Japan, we plant rice only one time, okay, in a year, mainly, except for Okinawa. In Okinawa, they produce 2 times, okay, as in Taiwan. In May, is a planting season, August, heading season, and September and October is harvest season. Okay. Heading means this kind of structure is appeared. Okay. And high temperature, okay, I will use this symbol, T, to represent temperature, okay, throughout this presentation. High temperature around heading stage will reduce rice quality by generating milky white grains. Okay, so this is a normal grain, and this is a milky white grain. So you can see here there's a white spot, right? So it will accounted as a colored kernels. So grade will be worsened. And a record-breaking heat wave in 2010 reduced the share of first grade rice to 30 to 50% in most regions. So heat is not good for quality, rice quality. Okay, so I will show some videos how inspections proceed. Okay. So rice bowl is very popular lunch or breakfast in Japan. I think it's more chewy. Okay, rice is more chewy than Taiwanese rice, so everybody likes it. So recently, summer temperature is very high in Japan, so rice quality is very bad. Mostly second grade because of heat. So they inspect rice in this way. This is good rice, and I think this is a colored rice or small rice. They account the number of bad grains and decide grading. This is this year, okay, 2023. This is moisture level. This is first grade, second grade, the price is different. Yeah, so this is white milky veins. Yeah, it's very unbelievable high compared to before. Less water makes rice white. Yeah, that is overall situation in Japan, Japanese rice production. So now I want to show you some So let me explain the trend of rice. Okay, so this axis shows regions of Japan. Okay, we have 47 prefectures in Japan. So this is the most northern part, so it's cold part, and this is warm part, southern part of Japan. So this small one is Okinawa. Okay, close to the Taiwan. And this axis is a rice yield. So on average, we can have 500 kilogram per 0.1 hectare. Okay. So this is around average. And circle size represents the planted area of rice. So larger area means larger production. Okay. So Okinawa don't have so much production. And the color, this is the most important. Color is represents temperature. Compared to normal years. So green colors means a little bit cold, while orange or red represents hot years. Okay, so this is a situation in 1976. Okay, so let me show you some movement. 1997, 78, 79, 80, 80. We have a cold year, so rice was decreased, right? A little bit. 82, 83, so temperature is relatively normal in these days. 88, 89, 90, and 93. This year was the worst harvest of rice, and we had a very cold temperature during the summer. So temperature, low temperature is not good for rice yield. Okay. 98, 9, 2000. After 2000, we have lots of hot years. Now, this is 2003, is relatively cold in northern parts. Okay. But except for this year, we have a very warm years. So colors becoming orange and red. But the yield is not so decreased. In 2010, as I said, this is a very hot years, but the yield didn't decrease so much. So from here, we can guess that yield is not so affected by hot temperature, but by cold temperature. Okay. So next, the same thing about the share of first grain. Okay, so this means the share very good rice. Okay, and in contrast, you will see that quality is affected by high temperature, okay, and not so affected by cold temperature. Okay, 79, 80, cold temperature doesn't affect so much, right? 84, 85. Please focus on 93. Okay, 93 was very cold years. 90, 91, 2, and 3. It doesn't decrease so much, right? But after 2000, hot years will increase and grade is decreasing gradually, especially in southern part. So hot temperature is not good for quality. Okay. And 2010, we experienced a very big shock in quality. 6, 7, 8, 9, 10, right? Compared to previous years, 2010, grade is worse, very significant. So that is, from this picture, maybe you can understand there is asymmetric effect of temperature. Yield, I mean quantity, is affected by cold temperature, while quality is affected by high temperature. And there is agronomic literature on the relationship between temperature and yield and quality. And it is said before heading season, low temperature causes spike-red sterility and reduced yield. Okay. And after heading period, yield is peaks at 24 Celsius degree, and temperature greater than 27 will increase milky white grades and reduce quality. And regarding the impact of climate change in the future, rice yield is relatively optimistic. Okay. For example, this paper predicts that 3 degree warming will increase crop yield, increase, okay, not decrease, in northern Japan. However, for rice quality, there is pessimistic predictions on rice quality. For example, this paper predicts that fast grain rice will decline by 40% in southern Japan. So, compared to this agronomic literature, our contribution is as follows. So first, we compare quantity and quality in monetary terms. Okay? So in this agronomic literature, they don't compute farm income or monetary terms. So that is the main difference. And most agronomic studies are using experimental data. I mean, they do some experiments on field and compare the outcome. However, in reality, farmers might react or try to mitigate the impact of heat or cold temperature by using various practices. So experimental result and observational result, I mean reality, could be different, right? So I will use observational data, I mean statistics, to overcome these issues. And there are several methodological contributions as well. First, I will explicitly control for phenology or growth stage, and non-linearity or selection bias. These issues are also controlled for. Right? Or maybe my presentation file is a little bit old, but okay, it's okay. So basically, we try to estimate. Okay, you know I think you all know the econometrics, right? So dependent variable is either rice yield or grain shares. Okay, and our x variables are temperature, precipitation, sunshine hours, etc. So regarding the phenology, most economic studies rely on calendar-based weather variables, like average temperature from April to September. But the impact of temperature could be different by growth stage. So we define 3 growth stages by using planting, heading, and harvesting dates, recorded by each region and year. So in stage 1 represents vegetative period, which means planting to 3 weeks before heading day. And the second stage represents reproductive period. So this is between 3 weeks before heading to heading. So this is very critical stage of rice production. And the last one is a ripening periods, referring to heading to harvest day. And the nonlinearity can be represented by step function, polynomial function, or piecewise linear function. So probably you will, most simple temperature variable is average temperature, right? For example, average temperature in August, right? But it cannot reflect distributions. For example, if there is a month with 30 days of 20 degrees, and there is another month with 15 days of 0 degree and 50 days of 40 degree. They both result in average temperature equal to 20 degree, right? But of course, maybe later is totally worse, right, compared to the first one. So average temperature is not sufficient to capture the impact of temperature. So I use, I try to reflect daily temperature changes within a day using some special techniques. And lastly, I also control for sample selection bias. Maybe this is a little bit technical, so I don't go into the detail, but not all rice are inspected. So about 60 or 70% of rice are inspected, but remaining rice are not inspected. Meaning that our observations are not representing population, underlying population. So I should care for the bias caused by such issues. And the weather data is coming from 1,300 weather stations in Japan. And yeah, that is aggregated to make regional data. And finally, our data covers 47 prefectures in this period. So almost 35 years. So this is the performance of my estimation result. So this is a yield. Black line represents predicted value from the model, while gray lines represents actual value. So you will see that the fit is very good. And this is the same for first grade share. And yeah, you can see fit is very nice as well. So this figure summarizes the impact of temperature. So this stage, first stage, is from planting to 3 weeks before heading. And the last one is from heading to harvest. And yeah, this is the temperature distributions. And as you know, for example, this table picture shows temperature does not affect crop yield. Most estimates are not significant. But this figure shows Okay, in stage 2, temperature lower than 18 degree significantly decrease rice yield. So negative 20, almost 20. So that is nearly 3% or 4% damages. Okay? So if you experience just a single day of cold temperature in stage 2, rice yield will decrease very, very largely. However, high temperature, okay, greater than 33 degrees, is not a little bit decreased yield, but the effect is not significant. And this here, these 3 panels show the impact on first grade. Okay? So very high quality rice. And similarly, stage 1 and stage 2, the temperature does not have significant effects. Okay? However, in the last stage, after heading, if you experience temperature greater than 33 degrees, grade share decrease very significantly, okay? Nearly 10% points. Okay? So as I said, average first grade share is nearly 70%. So this is very big impacts. So using these estimates, I simulated the impact of climate change. And I simulate the impact of 3-degree warming because many climate change predictions predict around in Japan we will experience this kind of magnitude of warming. And I decompose warming impacts into 2 parts. Okay? So first one is a quantity effect, meaning that warming will change in yield, right? This is quantity. So it will affect rice revenue, okay, farmers' revenue. And quality effect change grade shares, then that will change revenue. So I decompose these 2 effects. Okay? So this is a result, okay, of the quantity effects. I don't have a scale. Here, this is a scale. Okay. Blue color shows more than 10% increase, while red one shows minus 10%, more than 10% decrease. Okay. And as you see, in northern part of Japan, we experience gain, okay, rather than damage on rice quantity. So in this region, Hokkaido, increase rice yield more than 10%. Okay. Although in southern parts, experiments slightly decrease, but as a country, as a whole, the average change is 3.4%. But the standard error is 2%, so this is not significant. And this one shows quality effects. Okay. By the way, this percent change means a percent change in farm revenue. Okay, not quality or quantity itself. Nice revenue. So this picture shows in most regions they experience decrease of farm revenue because of quality effects. And the average, national average is minus 8%, and this number is significantly different from 0. So the message is that quality matters more than quantity. And I performed several robustness checks, and but I will skip the detail, but the story is almost the same. Okay, quantity effects is almost not significant so much. The quality effects is very significant in most cases. So for such a warming effects, what can we do? Okay. So there are various adaptation strategies to avoid the damage of heat, but one simple strategy is changing planting dates. Okay. So if you change planting dates, the season will change, right? Heating season will change. So the more you can avoid the most sensitive season to exposed to summer heat. So this picture shows such an effect. Okay. So this axis shows a delay in planting date in week. Okay. So for example, this shows if farmers delay planting date by 2 weeks. Okay. Then this gray one is a quantity effects, and this black one is a quality effects. Okay. And this white one is a total effects, okay, of quantity and quality. And as I said, if you don't do nothing, rice is slightly increased, but quality is largely decreased. So total effect is negative. Okay, so farmers' revenue will decrease nearly 5% or so. However, if you delay planting dates, you can avoid negative quality effects. And for example, if you delay 5 weeks or 6 weeks, then you can totally eliminate such a negative effect. So quality effect is almost zero. So overall effect is positive. So conclusions. First, regarding the temperature effects, yield is sensitive to low temperature, while grade is sensitive to high temperature. Okay. However, not sensitive to temperature in initial stage, right? As I show here. So initial stage, temperature doesn't have a significant effects. And regarding the impact of climate change, farm revenue is decreased by quality effect. Okay. However, negative effects can be avoided by delaying planting dates several weeks. And the most important message of this study is that unless crop quality is accounted for, the estimated impacts of climate change and adaptation strategy could be misleading. Okay. Because, for example, if you see this, if you don't include quality effect, you will only see quantity effect, right? So you will conclude climate change is good for farmers, right? But if you account for quality, the total conclusion is totally reversed. Yeah, so that is all for my presentation, and the detail of this analysis can be found in this paper. Okay, so if you're interested, please take a look. Okay. Thank you very much.
Okay, the original article is published in American Journal of Agricultural Economics. It's very top, journal in this field, and is quite famous in Japan. I mean, many Japanese scholars refer the paper. Okay, and it's very impressive and very interesting. So, welcome the students. Any question or comments? Okay. Or Professor Chen, do you have any? Oh, good. A student from Mongolia?
Mongolia. question. You said most of the rice farm plant one time a year.
Yes.
But Okinawa locates in southern of Japan. But why Okinawa plant 2 times a year? I think so. In this case, Okinawa's rice's quality is not very good because it's very weather is very hot and 2 times. So I wonder why 2 times.
Taiwan also do that.
Taiwan, I know Taiwan 2 times, right?
Yeah.
I know. But in Japan, most of the farms only 1 time. Only
Okay.
Okinawa.
So in general, crops grow faster under high temperatures. So that means if temperature is high, total growing season is shortened. So in Okinawa or Taiwan, you can plant twice a year. So total season is shorter. Yeah.
One more question.
One more question, good.
And so to plant more high quality, for example, first grade rice, maybe we can, if I want to plant rice in Japan, and I want to harvest first grade rice, so in this case, maybe I should buy the land in the northern of Japan. And what else I have to consider to harvest first grade rice? Yes. The first one, of course, it's weather. The weather should be not very high, not very hot. What else I have to consider?
So there are, I think, many issues, but another one is that I think in this YouTube, they talk about that, I think. Oh yeah, so there's a bug, insect damage. If you have an insect, they will make rice black. So it turns to like this.
So you need a pesticide.
Pest, yeah.
Not organic.
Yeah, I don't know how to say rice bug. It's called rice bug, I think, in English. That is another issue.
Teacher, this place, they use pesticides, so they.
Oh, they use.
Still
Yes.
So how to prevent?
How to prevent? Maybe you should use in appropriate timing. Pesticide should be used appropriate timing, or if you find the insect, you should additionally use pesticide.
So in Japan, the organic rice is not very common.
Oh, that's right. Yeah, in the term of area share, organic farming is almost 1%. But that is very recently good. The Japanese government tried to make it 25%. Organic land should increase 25% by 2050. So So it's recently it's a very big policy issues to make organic more, but that will cause another issue as well, I think. Thank you very much.
Oh, good.
Hello, Professor. I'm very curious about delay planting. Delay planting. So if climate change is still serious, delay planting is useful, very useful. Yeah.
So, as I said, so for example, as this picture shows, this is around heading season. Okay, heading means that rice sprout is coming out. So it's a kind of baby, okay, baby of rice. So baby is not very sensitive to high temperature and cold temperature. So if you delay planting dates, you can, well, normally this stage is around top or beginning of August. Okay, so it's the most hot days, right? But if you delay planting day, let's say 1 month, then simply said heading season will be the beginning of September, right? So you can avoid heat, summer heat. That is a basic idea. So sensitivity is different by the timing of the rice growing stage.
Okay, thank you.
Yeah.
Any other question? I can give you bonus in my class. Okay, I have a question. I just want confirm that. So it's panel data, right?
Yes.
So it is prefecture level. Okay, so the ID is prefecture. Okay, so I mean your Y is yield or the average, right? Average for each prefecture
Oh yeah.
label.
Yeah.
Okay, so because so it's a fixed effect. I mean the results. I mean you need to control, because you mentioned can talk a little about the Heckman two-stage, you perform Heckman two-stage, right?
Yeah.
So you mentioned you try to Heckman selection, the intelligent this selection bias, right? Can you briefly talk about how you to solve the selection bias problem? Thank you.
That's a very advanced question. So as you said, Heckman selection model is applicable only when 0-1 selection decision is observed. So it can be used only for micro data. Okay. Whether you go to university or not, or if you work or not. So that kind of yes/no decision should be observed. However, here we have only aggregate data at the prefecture level.
Yes.
So, so we developed a new estimator by extending this Heckman's original model.
So it means that maybe you have some Y is 0, right? So you need to consider the
Y is
maybe some prefecture have no data. I mean the yield for specific yield.
Well, we don't have such an extreme year.
Okay, okay.
But of course, so inspection, we call it inspection rate. Okay, inspection rate.
Okay.
So it's not 0 or 1, it's a share.
Oh, share. Okay.
Share of total rice that goes to
Okay.
inspection
Okay.
or grading standard.
Okay.
So I modeled such a share
Okay.
by extending Ekman's model. So yeah, that is shown. That is a little bit technical, but
Yeah.
yeah, but basically it's a Heckman's.
Okay. And then to get the inverse means ratio, right?
Yeah,
And then
inverse
to
means
equal
ratio
to-
is used. Yeah, here.
Okay. It's kind of two-stage model. Two-stage.
Yes,
Right.
yes.
Okay.
But interestingly, Heckman's original model requires two-stage models,
And
right?
IV.
IV.
You need some IV.
You need the IV.
Yeah.
However, interestingly, if we consider aggregate version, it is not necessary.
Okay.
We can compute lambda by actual share. It's a little bit technical.
Technical. Okay, okay.
Yeah, please take a look at my. Yeah, this is also omitted from the main paper because the
Okay.
referees think it's very technical. So I moved it to the appendix. So
Okay.
yeah, this is also available
Okay, okay.
online. So, let's talk tonight.
Okay, okay.
More detail.
And
What
okay,
is the-
question. Okay.
What is the software you use when you show the relationship between?
Oh, that one? That one is depicted by Stata.
No, another a video you show.
Ah, video.
Yeah.
Video, well, I made.
No,
no, no.
Yeah, I know. This one, right?
It's very basic.
I made this video 10 years ago.
10 years ago.
10 years ago.
Oh.
Yeah. At the academic conference. But today, Professor Chen requested me to make a presentation on this. So, anyway, this is, I think, okay, I forgot, but it's kind of Google service, I think. It's called motion graph. Motion graph. Motion. If you the exactly same service is, I think, not available now, but different softwares or different platform offer motion graph service. Motion.
Thank you.
Okay. I have a question that because AJA is a very top journal and it's a very challenge to submit. So could you share your experience that how to successful to submit like AJA some pointer or some.
So yeah, because I'm Japanese, I'm not good at English, writing English. So I think I have a disadvantage compared to native Americans. So when I write a paper, especially when I'm targeting top journals, I try to do double than normal paper. That means first topic should be very important. And the second, I also try to contribute methodologically. So develop some new estimator or do something. So if we do twice, double the native Americans, maybe even if your English is not good, they can accept, right? So yeah, I try to make two contributions. That is my basic strategy.
Or any other can encourage students some how to do the interesting story, or to find the topic, or something student can do to do the challenge or the research.
Yeah.
Because Professor Kawasaki is very ambitious and do very nice research in Japan, okay? Especially for the agricultural policy. Okay? So very good sense and very nice experience. Okay, before he was a researcher in the Japanese think tank, the government.
Well, so research is consisted of two issues. One is the story or topic you select, and the second is the methodology. Okay. And well, finding a good topic is there's no magic solutions. If you read some books, if you are talking with some friends, or if you are watching YouTube, you will suddenly have an idea. So I don't have a good advice about finding a good story, but you should always think about your research. Okay, then maybe someday you will find an interesting story. Okay? And methodology is very more straightforward. Okay. There is solid estimation method, so you should study econometrics especially, and if you have some issues in your estimation, you should do your best. Okay? If you don't, for example, if you ignore endogeneity issues, your paper will be never accepted as a good journal. So if you find any issues, you should try everything that you can.
Yeah.
So that is my advice.
Okay, thank you so much. Any other question? Utsuri? No? Oh, good. The undergraduate student.
Oh, really?
Yeah.
Hello, Professor Kawasaki. I wonder if the global warming continue because the southern Japan can harvest twice. Will the conclusion quality matters more than quantity be changed? Or what do you think about this issue? Thank you.
Good. Give you bonus. Bonus.
So yeah, this is my paper. Today I talk about.
But I also have this paper.
Wow. Also AJE.
Yes. So in this paper, I investigated whether climate change allows more double cropping. And so this is the northern regions of Japan, and this is southern region of Japan. So and this gray one shows planting growing season of rice. Okay, and this one is growing season of winter wheat. Okay, so in northern Japan, their crop season is overlapped. Okay, but if you go to the south, okay, especially for wheat, growing season becomes shorter. Okay, as I said, because plant grow faster under hot environment. So in northern, southern part, double cropping of rice and wheat is possible. Okay. So I investigated whether this trend will continue in the future. Okay. And I found that this has very big potential to avoid the climate change negative impacts. However, regarding the double cropping of rice, this is rice wheat system. But the rice system, I don't have enough data. We don't have enough data, but probably in Taiwan, double cropping of rice is very common. So I think you have more rich data compared to Japan. So I think we can evaluate such a possibility using Taiwanese data. Yeah, thank you very much.
Oh, good. Final question.
Professor used one of the methodology is calculating the average weather.
Oh yeah.
Yeah, the average is, but this average temperature, professor said it's not sufficient. So you use another very professional kind of methodology. So what kind of methodology is that? Maybe we will use that methodology in our research work. So maybe can you explain more about this methodology?
So, for example, if you have a minutes level data, minutes by minutes, okay, minutes, minutes, hour, minutes, okay. If you have a minutes level data, you can record everything, right? Of the temperature changes within a day, right? But yeah, that is one possible strategy, using minutes level data to count, okay, let's say from 30 degrees to 31 degrees, how many minutes you experience between, let's say, August, September. That is one possible strategy. Okay? And another strategy which is used in this paper, we have a daily maximum temperature and daily minimum temperature, right? And from here, we assume temperature moves like sine, cosine, how to say, sine, cosine. I don't know English, my English is correct. I fit some very smooth line.
Okay.
And using maximum and minimum, we can know how many hours they experience, for example, between 30 and 31 degrees, right? And we repeat that for every possible ranges.
Very hard work, right? Work very hard to
Not so complex. This task, if you have maximum and minimum temperature, it can be easily calculated. How many days? So here, for example, we have a heading date. Let's say it's August 2nd. Okay, and this is harvesting date. We have our data, for example, October 3rd. Okay. Between this period, we counted all possible, well, this green line is coming from that calculations. For example, this bar shows from 30 to 31 degrees, we experience this amount of hours. So we repeat that and produced this histogram.
So you have different kind of temperature variable, right?
Yes,
That's only one.
Yes.
You know, so they use different type of temperature variables, yes, to control.
Yes. Basically, this green one, you should create this green data.
Variable and temperature, different kinds of the measure, you know. Okay. Okay. Final, okay? Final question. You? Okay. Oh. Okay. Okay.
If I want to keep high quality rice like white bowl rice, so is there any solution for this? Because the climate change is more serious. So if I want to solve these problems, what do we do now? Yes.
Yeah, so first, there are several strategies to avoid quality issue in hot temperature. So first is, as I said, changing planting date. And another is water management. If you have hot days, you increase the water level in the rice field. Then it will avoid damages. And the third one is that government should develop new rice variety which is resistant to heat. I think these are main strategies.
Okay, thank you so much. Okay, so thank you for the chat. Okay, so if you have any question, you can ask. Okay, later. Okay, so we give the.